Oh, hey. Almost didn't see you there. We're here for another late night special of Algebra 2 Honors Semester Exam Review. Part 2, right? Because one video wasn't enough. Let's hop to it, all right? Shall we? Let's go. All right, what is the max? And now Jenny starts whining. What is the max and min of the objective function p equals 3x minus 5y with the given constraints? And perhaps, in the final exam, we might have a little story behind it. Jenny, shh, we're doing math. We're doing math. We'll hang out a little bit. All right, so I've got negative 2, 1. I'll just jot these ordered pairs down. Then it looks like we got 1, 2, 3, 4, 5. 5, 4. And then we've got 4, negative 2. So here's what we're going to do. We want to find our max and our mins. I'll probably ask for one of them on the test, but let's see. Let's go ahead and do the objective function for each one of these ordered pairs. So if I start with negative 2, comma 1, that would be, let's see here, 3. It's terrible. 3, and then we'd have negative 2 in for x, minus 5 times, and then 1 in for y. And I'm going to get negative 6 minus 5 is negative 11. Okay. Then for 5, 4, I have 3, and then 5's in for x. And then I have 4 in for y. I'm going to get 15 minus 20 is negative 5. And then we've got 4, negative 2. It's a terrible negative 2. Okay. And an arrow. Man, I'm all over the place. Whatever. All right. 3, we get 4. And then we got 5, and then we got the negative 2 in for y. So here I've got 12. It looks like minus negative 10. So that would be 22. So the max is 22, and it's occurring at 4, negative 2. So if it asks, like, at what point is there a max, that would be the point. If it's just asking for the max, the number 22 would be there. We wouldn't put both answers on there and like make you choose between 22 or 4, negative 2. But that's what those two things mean. So then we have the minimum. Well, what is my minimum? My minimum is negative 11. Where is that occurring? At negative 2, comma 1. Beautiful. And I do believe occurring has 2 R's. Spelling, not Mr. Allen's strong suit. Hopefully all of my math is correct. Doing these things quick in the cabeza. Let's roll. Let's roll. All right, for this next one here, this is a pretty loaded question because there's a lot of questions we can ask on it. So given this polynomial, this cubic polynomial, let's find our max, our mins, and our zeros here, shall we? Okay, that sounds wonderful. So let's see here. From our graph, if I plug it in my TI-84 plus graphing calculator, I'm going to go zoom 6 with this thing, just so it's a standard window, right? So here we go. If I look at this, we got it's crossing. It looks like it's actually crossing at some nice spots. I'm going to do max and mins, though, to start, okay? And then we're going to actually do something a little bit different here. So let's see. For our max, I'm going to scroll down to maximum. Boom. It's already at, looks like almost the max height, but let's just be sure. So we want to go to the left, hit enter. Then we go to the right, hit enter, and then guess, and it gives us, see, it is not. So our maximum is negative 0.097, so negative 0.1 and 5.05. Yeah, that sounds good. So negative 0.1 and then 5.05. So that's our max. And our min we'd calculate the same way, but what do we need to do here? It looks like it's actually off the screen, so perhaps we need to change our window, and we got to go down on the y-axis a bit. So I'm just going to go negative 30 just in case it's like way down there. All right. And it regraphs. Beautiful. Look at that. There's our low point. So minimum. All right. Left bound, so we want to be to the left of it. All right, sorry about that. I had to pause for a sec there. So I got my left bound, hit enter, go to my right bound, hit enter again, and we guess, and boom, we have 3.43 this time, and negative 16.90. So 3.43 and negative 16.90. All right, we could have put a 0 here at the end of that one. Boom. Love it. All right, so we got our max and mins. Good there, right? Now we can also find our zeros. Now, rather than doing that with the calculator, I'd like to take a sec here to do a little bit of factoring review, right? We could use our calculator. That is an option, but perhaps actually a quicker way right now would be through factoring. So if I were to jot that down over here, x cubed minus 5x squared minus x plus 5, and then we'll verify one of them with the calculator just to go through that process, okay? Equals 0. So I can use factor by grouping here. Boom, boom. And I'm going to take out my GCF of the first one, which is x squared, and I'm left with x minus 5. The second one, I take out a negative 1, and I'm left with x minus 5. That equals 0. So now I have x squared minus 1, and x minus 5 equals 0. Now, I can factor this other one further, x minus 1 and x plus 1, and then I have x minus 5. You could have set both equal to 0 and solved like using square roots for that left one. But just to go over, like, if you were asked to factor completely, that would be your final answer there, okay? Now, to get my zeros, I'd have x equals 1, x equals negative 1, and x equals positive 5. So there's all my zeros. Let's pop up that calculator one more time, and let's just do one of the zeros, so second calc, and this time I'm going to choose the second option, so 0. Enter. And now I'll just go with this one over here, which we believe is to be 5, right? So I hit enter for my left bound. Now I got to go to the right of it, which is above it. Hit enter. And then once again, we guess. Notice how the arrows are pointing in towards the point. 5, and then, what is this? 3.6 e negative 12. That is scientific notation for moving the decimal place 12 spaces back. Okay, so that's like 0.000000000, right? A bunch of zeros. So it's 0. Your calculator is approximating. Sometimes that happens. Cool, awesome sauce. All right, that's awesome. I think we can actually do a little more with this. What do you think, Jenny? Jenny, you think we can do a little more with this? Yeah, Jenny does. She's chilling here. She's a little upset. She wants to go out and play right now. I told her in a little bit, so we'll be checking in. Hopefully, she's just hanging there. All right. Here's what I'm thinking. We're going to use these max and mins, and let's do a little recap of intervals of increasing and decreasing while we're at it. Shall we? Yes, we shall. Cool. So I'm going to draw this graph, which looks something like this, right? Okay. And then, yeah, that looks about right. And then I'm going to mark my max and min points because that involves my my max and my min. So we had a max at negative 0.10, comma 5.05. And I had a minimum at 3.43 and negative 16.90. Okay. So either you'd have to calculate those or we would just give them to you to see if you know how to do intervals of increasing and decreasing, right? So let's say we gave these to you. Now you need to give me the intervals of increasing and decreasing. So increasing intervals. Well, my increasing would be right here. It's going up, 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 right? So that would be from negative infinity, because negative infinity is over here, not because it's down low, but because it's far left. I don't know if my arrow's pointing is correct. Sorry. I always say that in these videos. I should probably just watch them back and find out. All the way up until negative 0.10, okay? And not including that point. So these are x coordinates to tell us where it's increasing, where it's decreasing. Is it increasing anywhere else? It certainly is. It's going up on this part as well. So now we have union. Let's see, here we go from 3.43 till to infinity and beyond, right? Awesome. How about decreasing this time? Decreasing. Well, my decreasing intervals, that's along this stretch right here. So I'm going to go from, let's see here, negative 0.10 till 3.43. Boom. Done. That's awesome. So intervals of increasing and decreasing. We got our max and mins from our calculator. We have zeros from both factoring as well as we showed it with our calculator. That covers a lot of polynomial. Ooh, one more thing, actually. How about end behavior? End behavior here. Okay. End behavior. And then I promise we're done with this one. So end behavior with this, as x approaches negative infinity, what's f of x approaching? As we go this way to the left, it's going down. F of x is approaching negative infinity as well. As x approaches positive infinity, what's f of x doing? That, as we move to the right side of the graph, it's going up. So it's going to positive infinity here. All right. Well, there we go. That was a lot of fun. It was a ton of stuff. Let's see. Let's check in with Jenny here. We can make a bigger. Jenny, you fell asleep in class? My goodness. None of you would ever do that, right, Jenny? Still out. She went for a run earlier. Having a good time. Okay, let's do some more math. Ooh, division here. Synthetic division or long division, your call. I'm going to go ahead and choose synthetic division here. It's a linear binomial. Nice and easy because it's x plus 2, so we can get negative 2 as our number that we're going to use for synthetic division. I've seen people set this up differently, so I apologize if mine looks a little different than maybe what your teacher did, but I'm the one making the video, so I get to choose how I do it. All right. So x to the fourth, that's a coefficient of 1. There's no x cubed, so we pop a 0 here. And then we got negative 3 and 5 and negative 1. All right. I think we got everything there. Everything looks good. Cool. So we're going to start by dropping down this 1. Then negative 2 times 1 is negative 2. Then we're going to add. We get negative 2 times negative 2 would give me positive 4. And then we're going to add vertically. Negative 2 times 1 gives me negative 2. Add vertically, I get 3. Multiply again, we get negative 6. Add them, we get negative 7. So this is my remainder. This is my constant, my x squared, and my x cubed. So my final answer here would be x cubed minus 2x squared plus x plus 3 plus, or we could say actually minus 7 over what we divided by, x plus 2. Cool. All right. So things that we could ask you on a multiple choice exam. What's the remainder? Right? Which is negative 7. We could say, is x plus 2 a factor of x to the fourth minus 3x squared plus 5x minus 1? It is not a factor. Why is that? Because it had a remainder. If the remainder was 0, x plus 2 is a factor. In this case, it's not. We could say, what is, if this was a polynomial, let's say this is p of x, what's p of negative 2? Question mark. Well, that would be negative 7, right? Our remainder is equivalent to what we when we do direct substitution. Okay, so if I substituted in negative 2 to this, I'd get a remainder of negative 7. So a lot going on here, a lot of things that we could ask you. I think that's pretty much it with synthetic division. Oh, man. Factor. Cool. All right. Difference, sum and difference of cubes. So this is something that wasn't on our polynomial test, but it is going to be on our final. So let's refresh this, okay? Shall we? I think we shall. All right. So I like to go ahead and write down what the cube root version would be, okay? So actually, you know what? I'm going to jot down our patterns real quick. All right. So just in case you want to jot this down for your own notes, I figured having the pattern laid out here with A's and B's might help. Some people hate this, but sorry if you do. All right. So this one we're dealing with the bottom one here, obviously, because it's subtraction. So what does this mean exactly? Well, A is going to be, the cube root of 27 is 3, and the cube root of x is x. So A is going to be that, and B is going to be, cube root of 64 is 4, and then cube root of y is y. And we can sub these into our formulas accordingly. So I'm going to have 3x minus 4y. And then I'll have the 3x being squared, so 9x squared. Plus, and then it's the product of those two, so 12xy. Plus, and then we have the 4y being squared, all squared. So that's 16y squared. All right. That is it. That is our fully factored form. Okay? If you can remember that pattern, awesome. Some other test taking strategies. If you're like, dude, I can't remember how to factor that. You could multiply each choice together if you have the time. That could take a little while, but that is an option. If you forget how to factor these or what the exact formula is, you can always multiply the two together. But A binomial times a trinomial, not necessarily like the quickest thing to do, but it can work in a pinch, okay? That's enough time spent on that problem. All right, one of everybody's favorite. Write the equation of the polynomial in standard form with integer coefficients with zeros at 2i and 3 over 4. Okay, wording's a little but let's do it. All right, so zeros, 2i, and 3/4. All right, so with 2i, and again, some teachers will do this a little bit differently, but if I were to write this out, I'd have x minus 2i, but I also have a 0 at negative 2i, so x minus negative 2i is x plus 2i. And then I have the 3/4. I got to think this one backwards. If I'm going to be dividing by 4, then I'm going to need a 4x. And if it's going to be a positive 3, I'm going to need this to be a negative 3 here, so that when I set this equal to 0, right, if I were to set 4x minus 3 equal to 0, I'm adding 3, and I'm dividing by 4, right? And that's how I get that 3/4. Okay, see how that we work backwards on that? Cool. All right. So this is like factored form, but with imaginary numbers, so we can't have that. But this also just asks straight up for standard form. So let's do it. So first thing I'm going to do is I'm going to multiply these two together, okay? And when I do that, I end up with x squared minus 4i squared. So we get x squared plus 4, right? I squared is -1, so that becomes plus 4. And then I'll bring that other guy right down here, 4x minus 3. This right now is considered to be factored form. So had the question asked for factored form, we're done. That's my answer. But since this one said standard form, I'm going to need to multiply them together. So I'm going to have 4x, to the third power, and then minus 3x squared. And then I'm going to distribute the 4, so I get plus 16x minus 12. So this right here is my standard form final answer. No like terms to combine. We are done with this problem here. That is a wonderfully fantastic relief. I like it. Let's do another one like that, but maybe without imaginaries. All right, so same directions. Now we're going to write the polynomial equation in standard form. I just didn't want to write it all again. With zeros at x equals 3, -5, and x equals 0 with a multiplicity of 3. Interesting. Okay, so we could have multiplicities of 3, 4, 2, whatever. Let's write it out first in factored form. All right? And let's go ahead and I'll change color here. Let's go with yellow. So I'm going to have x minus 3 of x plus 5. And then we'll have x minus 0, or just x. And that's going to be with a multiplicity of 3, so x cubed. Okay? That's factored form. Usually we would see the x cubed out front, but this is perfectly acceptable. Okay? Now let's go ahead and multiply this out. I'm going to multiply these two together first, and then we'll continue. So I have x times x is x squared, and then I have plus 5x minus 3x minus 15. All of that still times x cubed. Let's combine some like terms. I get x squared plus 2x minus 15. Whoa. And then I can go ahead and distribute that guy in. Again, it looks a little weird because it's backwards, but hey, same final result. X to the 5th plus 2x to the 4th minus 15x cubed. Final answer in standard form. I love it. Beautiful. That was awesome. All right, let's do a little simplification. I think we're good on all this, right? On all the polynomials. We'll do a little bit of functions, and then that'll be it. All right, so first I'm going to distribute these negatives. So I have 2x cubed minus 5x minus 4x cubed minus 2x squared plus, and then I'm going to distribute that guy here. We got 6x plus 3. So let's just make sure that we did everything correct there. We distributed our negative properly. I think we're ready to combine some like terms. So I have 2x cubed and negative 4x cubed is negative 2x cubed. And then, so those guys are gone. Now, nothing goes with my quadratic, so that's good. And then I have negative 5x and positive 6x. So that's plus x, and then I've got plus 3. There it is. Done. Be very careful distributing those negatives. That's really overall pretty straightforward problem, I'd say. Not too bad. I'm going to do a quick peruse of anything else from this guy, and then we'll do a few things with functions. All right, so let's do a little bit of function operations, right? And then we'll do maybe an inverse and maybe something with like a radical with a graph. Okay, just, making the mental checklist. Does that sound good, Jenny? Well, let's go a little bigger so we can see a little more, Jenny. Does that sound good to you? Yeah, no? Okay, whatever. All right, I think she's into it. She's like, functions, love me some functions. All right, so let's set this first one up here. So we have f minus g. So I'm going to use some parentheses just to be careful, and we're going to have x squared plus 4 minus, and then we have 2x minus 3. Big thing here is remembering to distribute your negative sign, right? So we have your subtraction. So we have x squared plus 4 minus 2x plus 3, and we end up with x squared minus 2x plus 7. Final answer. Done with that one. Beautiful. Fantastic. We circle it. And we'll make it nice and small. I was hoping I would be able to. Fancy technology. Right? Okay, there we go. And we'll toss it off to the side. Okay. Next one. Let's say we want to do f. Oops, should probably get a marker again. F times g. Not f of g, but f times g. So this one I'm going to be multiplying together. So x squared plus 4, and then we have 2x minus 3. We're just going to go ahead and FOIL, right? Except for we're dealing with like different exponents and stuff than our normal ones, but that's okay. So we're going to have 2x cubed, and then we have minus 3x squared plus 8x minus 12. That's it. There's nothing to combine, right? We're done there. Awesome. All right, how about f of g? Everybody's favorite, fog. So this one, g is going into f. So I'm going to have 2x minus 3 quantity squared plus 4, right? G is getting plugged in. This is where you're going to be very careful. You got to make sure that you are thinking of this as 2x minus 3 times 2x minus 3. Some of you are totally fine with like foiling this in your head without having to write it out. A lot of us, I think, like to write it out. So 4x cubed, and then you're going to have negative 6x, and negative 6x is negative 12x plus 9 plus 4. Combine a little bit of like term action here. Why did that cube? That should be squared. My apologies. So 4x squared minus 12x plus 13. Okay. There we go. That was a close call. Hopefully no mistakes so far. I don't know. There's usually one. All right. This one. Whoop. Make it small. And then how about one with evaluating a number? And let's go the other way now. Let's say that we're going to do g of f of 2. Okay? So for this one, the way I like to go about it is I like to plug 2 into f. So I'm going to do f of 2. It's a weird 2. And I'm going to have 2 squared plus 4. And that gives me 4 plus 4 is 8. And then I'm going to do 8 getting plugged into g. So now I do g of 8. And I'm going to have 2 parentheses 8 minus 3. And I get 16 minus 3 gives me 13 as my final answer. That's it with that one. Let's see, what else are we forgetting here? How about division? Because the division is not too bad, except for we do need to remember about restrictions, right? Okay, so let's do a little bit of division. How about we have f divided by g? What would that be? Well, f would just be x squared plus 4 divided by 2x minus 3. All right, so that's the division, but then we also have our restrictions, which we could just explicitly ask, what are the restrictions on f divided by g? So I'm going to have where x does not equal something. What is that not going to equal? Well, if I take my denominator, 2x minus 3, set it equal to 0, I can find out when it equals 0. Why do I care about when it equals 0? If I divide by 0, it is undefined. So that's our number we want to go with. All right. So we get 3 and then 3 over 2. So x cannot equal 3 divided by 2. This is our full answer here. The restrictions are the bottom part. The other part is the, I guess, the answer, if you will. All right, but it's two-parter there. May ask for just one or the other. All right, let's do a quick graph here. So we have graph y equals negative square root of x plus 1 plus 3. Might be helpful to do a little t-chart action here, right? And then we'll talk about some of the characteristics here, maybe how to quickly identify something on a multiple choice if there's lots of graphs with one equation or lots of equations with one graph. All right, but let's just go old school like this right now. So if I want to get square root of 0, if I want 0 inside, 1 inside, and 4 inside, well, negative 1 for an x value would give me 0 inside. So square root of 0 is 0, plus 3 is 3. Then if I want to get 1 inside, I'd plug in 0 for x. Square root of 1 is 1, but it's negative out in front, so negative 1 plus 3 is positive 2. Now I want to get 4, so I'm going to plug in 3 for x. Square root of 4 is 2, which becomes negative, plus 3 gives me positive 1. So let's go ahead and plot these. So I've got negative 1, comma 3, and then we have 0, 2, and then we have 3, 1, which this is interesting because it's like, that was a terrible graph. Let me try that again. There we go. So it's going down rather than the normal up. So what's happening here is, well, all right, so what we have going on here is it's actually a vertical reflection. This negative 1 out in front caused it to go upside down like that, right? The plus 1 had it shift to the left one, and then the plus 3 had it shift up 1, right? So one, we can ask questions about transformations. What are the transformations here? Vertical reflection, left 1, up 3, right? You could possibly have to just quickly identify this on a graph, and if you notice the vertical reflection, you knew that was a negative out in front. All right, inside would be flipped around horizontally. The shifts would be a quick way to identify it from the start point right there, right? All things that you can identify there. All right, one last problem, then we're going to call it a day on this one. Let's go find f inverse of x if f of x is equal to, how about 2/3 x plus 6? So first things first, switch our x and y's. X equals 2/3 y plus 6. Now I'm going to go ahead and resolve. So I'm going to subtract 6. I get x minus 6 equals 2/3 y. And then I'm going to go ahead and divide by 2/3, or in other words, multiply by 3 over 2. Now, what I saw a lot of people forget to do on their test is that they didn't multiply the 3 over 2 to both parts. So this is going to be 3 over 2x, and then we have minus 9. Yeah, because we're going to have 3 times negative 6 is negative 18 divided by 2 is negative 9 equals y. So my final answer here, my final answer is f inverse of x is equal to 3 over 2x minus 9. Cool. Awesome. That's fantastic. Little inverses, little fun stuff, right? All good things. Jenny is still chilling here, still sleeping. What up, Jenny? We're going to go play outside in a little bit? Yeah? That sound good? I think that sounds good. She's like, dude, I just love so much math. All right. Hope you guys enjoyed. Study hard for finals. America, freedom, rock and roll, Costco, Yoro, Riverdog Jenny on the gram, and have a wonderful, wonderful time taking finals. It's not stressful at all. See ya.